Hello everyone, thanks for coming. My name is David Lluna, he's Paco Sánchez. We both work at Flywire as SREs. Flywire basically helps with sending and receiving international payments. So we move money, basically. It was founded in 2009, and we have offices all over the world, but the engineering team is based here in Spain, on Valencia. So today we are going to talk about Terraform. We will first give a very short introduction about how the Terraform works and the basic components, and then we are going to show you something more deeply with a light coding session. Okay. At the end, we are going to show you some examples of how Terraform is being used in the wild and how are we using it at Flywire Terraform. So let's start. Terraform is a tool for building, versioning, and changing infrastructure. Some facts: it's an open source project. It was created by HashiCorp in 2014. Maybe you know HashiCorp by other products like Vault, Vagrant, Consul, Packer. It's written in Go, and it's designed to be flexible and modular. It's based on a plugin system, so it allows you to extend it. It's a tool that allows you to describe infrastructure in a very descriptive and in a very expressive way, using a language called HCL. It's basically an abstraction layer on top of the API of multiple providers. HCL stands for HashiCorp Configuration Language, and the reasoning for creating a brand new language is interesting. Why not use JSON or YAML, for example? So HCL is the response from HashiCorp to try to be somewhere between a human-friendly language and a machine-friendly language. So it's designed to be written by humans, but it also allows to have a machine-friendly input as JSON, for example. In this example, you can see how to use HCL to bootstrap 5 servers in Amazon behind a load balancer. This is the same example using DigitalOcean. So you can use Google Cloud, DigitalOcean, VMware, you name it. And if there is no already support for the provider that you are using, it plugin architecture allows you to write your own plugin and support your current provider. We will see some examples of this later. So Terraform has 3 main components. It has more, but this is the basic ones. It has resources, providers, and the state. In Terraform, a resource is it's anything from a low-level thing like a virtual machine to a high-level resource like a DNS record, for example. Then we have the providers that are responsible to the life cycle of a resource, so are responsible for creating, updating, and deleting these resources. And finally, we have the state, that is the file that keeps all the current state of the resources. So instead of showing boring slides, we are going to do a live demo. So we are going to build this. This is a very basic setup with a couple of machines on Amazon behind a load balancer, and all the networking needed for this. It consists of 9 resources: the load balancer, the EC2 machines, and all the subnets and the networking stuff. So with this demo, we are going to cover how to build, modify, and destroy the infrastructure, and in between, we are going to tell you some insights of the dependencies, how to do provisioning, and other things. So now Paco will take over and will demonstrate how to build that infrastructure using Terraform.
Okay, in the demo we are going to cover 3 parts. We are going to see the files that we have in our project, we are going to show you the most common commands in Terraform just to run our project, and we are going to edit our infrastructure in AWS, because this is where we are going to run our project. So here we have the three files for our project. We have the main TF file, and inside this file we have all the resources that we are going to create in AWS. As we saw in the diagram that David showed you, we have a VPC, Internet Gateway, routes. So going deeper in the file, we have a provider. As David told you, Terraform has different providers for Terraform. In this case, we're using AWS, but we can use Google Cloud, or even, I don't know if you know Datadog, it's a monitoring service. We can use a provider called Datadog, and we can use the resources. Then we have the resources there. As you can see, they are composed by two strings. The first one is the type of the resources that we are going to create. In this case, it's a VPC, and the name that we have for this resource in Terraform. We can have the same name only if the resources are different. For example, we can have two VPCs with the same name. We can have this. We need to change with the name. This name is not the name that we have in AWS. It's only for Terraform. For defining the name, we have I don't know if someone doesn't know AWS, but you have tags, and there you define the name or other tags do you need. So we have another resources like the Internet Gateway. If you want to get another value from another resource, we can extract it from another resource. For example, the Internet Gateway is bound to the VPC, so we can just VPC DevOps is the name and the ID. So this Internet Gateway is going to create inside this.
All the resources are some inputs and some outputs. The ID is one of the outputs, but you have, depending on the resource, there are quite a few different outputs that you can use in other resources to make dependencies, for example. So we have another resources, the routes, subnets. All these resources are available in AWS. Terraform almost covers all the values that AWS provides to you. So maybe there is one parameter that you don't have, but almost everything you can define it by code. More resources. The security groups. We have one for the load balancer that we are going to create with the ingress rules and egress rules, bound to the VPC of 2. Another security group for the instance that is going to be inside the load balancer that is bound to the security group of the load balancer. So the access is only through the load balancer to this instance. And of course, the egress. The instance is going to have a keeper. So if you want to access via SSH, you can have it too in Terraform. And the instance that we have. These are all the parameters that AWS provides to you. The AMI is the image that the instance is going to be created, the type, the keynet that we have created up there, security group, subnet. Here we have a dirty script that is going to now enable a web server inside the machine once is bootstrapped. So, and it's like a web page with an image, and that's it. So this that you are seeing here, it's only some of the required parameters, but there are a lot of other optional parameters that you can see in the documentation. There are quite a few for each resource, for example. The tags and the load balancer, and the same. The subnet, security group, instances, the listener that the load balancer have. So as you can see here, Terraform also supports variables. So instead of having the value in plain text, you can have a variable and configure it for different projects. For example, if you want to deploy this project
but in different regions, you can modify the variables and name it in different ways. So for variables, we have another file, and here are the variables that we have that our project have. The public key, the project name, and key name. We have a description, and also you can put a default value. There are different type of variables. You have the plain text, maps, and arrays. And as David told you, the resources have the possibility to export their output. So, for example, we have one here. It's the project address for the load balancer. This is going to export a URL of the load balancer, and later we are going to access it, and we'll see the image. So we are going to go now to explain some basic commands that Terraform have. So it has the most command is Terraform init, Terraform plan, Terraform apply, and Terraform destroy. More or less by the name you can imagine what they do. So Terraform init, what it does? It prepares your project for Terraform. It creates a local folder called .terraform, and it configures some configuration files for your project, so Terraform can work. It's downloading the AWS provider just to use the resources. If you have more providers, it will download too. So this is initialized. So yeah, we can just run our project now. We have Terraform plan. As we see here, Terraform is asking us for the variables that we have defined in our file. We can just fill it, and later we will see how can we work with this. DevOps. Okay. Okay. Terraform plan is going to say what is going to be created in AWS. All we have in our code is going to be created. The VPC, subnets, all with the values that we have configured. As you can see here, there are some values that are compute. These are values that AWS or the provider you use is going to calculate it. We don't know the ID of the instance yet, so once the instance is created, AWS is going to give us the ID and other resources, the load balancer, DevOps. Terraform internally knows which resource is going to be created first. So, for example, we can't create the internet gateway if the VPC is not created yet. So Terraform knows how the dependencies works. Here at the file we have a summary that is like 9 resources is going to be created, 0 to change, and 0 to destroy. As we don't have anything created yet, 0 to change, and we are not going to run any destroy, so okay. Finally, we have the Terraform apply, and this command is going to, as its name says, is going to create all we have in our plan. Okay, before running apply, putting the variables every time is a pain in the ass, as you have. Now we have 3, but imagine if you have 20 or I don't know 100. We have a project that have 200 variables. So Terraform provides you many ways to avoid this and make it easier to run the Terraform. For example, we can run Terraform apply, and they provide the Terraform var parameter. So we can just key name and DevOps, for example. We can rerun it, and as you can see, key name is not in a socket now. So this is a way. It's not really, if you have maybe 3 variables that we have here, maybe it's comfortable, but imagine as I told you, if we have 20 errors, it's not easy to read this command. In the other hand, Terraform provides a file called Terraform tfvars. So for example, in this file we can put the values, and Terraform will read this file and will populate the variables. If we save it, tfvars, If you name it Terraform TF bars, Terraform will read automatically because it's a default value. But if you have different TF bar file because you want to split them in, I don't know, imagine instance bars, VPC variables, you can specify to Terraform to take different files. So now that we have the variables configured, we can run Terraform apply, and now it's not asking us the variables. Before applying it, is show you what is going to be created. It's a new feature in new versions. So, okay, do you want to perform this action? Yes. Now Terraform is going to call the AWS API, and it's going to create, as I don't know if you use AWS the command line, it's going to use the same way. So here we have what is going to be created. The route is complete. The gateway, just what is going to be. If we go to AWS, we can see what is happening there. Okay. Here we have the instance running. That is the one we have created, Terraform DevOps, and we have specified in the variables. We have the keeper created too. That is for the instance. We have the VPC created. Amazon is really slow. Here we have the VPC, the subnets, the route tables, and the load balancer with the instance inside it. Load balancer. Okay. The font size is fine for the people. Okay. And the machine running is initializing, so now it's telling us that it's out of service, but in a while it will work. I don't know if you have used the command line in AWS. Well, you have environment variables, and well, I'm not going to show you the credentials, but you have environment variables with the credentials set up. So
in the
Is it using .aws, no?
no, we are using the environment variables.
Yeah.
The Terraform looks for that environment variables when you run. They have a default setup, but you can you show the main TF?
Yeah.
Where you assign
In this
roles or permissions to create?
Yeah, in this this provider is empty, but you can define the.
Yeah.
You can choose put that in this.
You can I can't remember the correct name, but you can act here access key there and the value.
And for each provider is almost the same for Google Cloud or the provider initialization. It's done in that resource. There are some schools that say that if you are only in AWS, use CloudFormation, but then there are others that maybe will say you that you are not vendor locking, or you can switch easily to another provider with almost the same configuration files. It's there is no clear winner in that discussion.
So we are in AWS, but we use external services like monitoring or for logging systems that I imagine that your company used to. So I don't know if CloudFormation has the support for another providers that they are not inside the AWS. For example, if you want to use Datadog, maybe in CloudFormation do you not have support for it? But I can't answer you because I don't know if
we, for example, use Cloudflare and Datadog and Sumologic. And we use the same provisioning tool. We don't have to use a lot of tools, one for each provider. That's a good question, because in the older versions, it's written in Go. It's a binary, and in previous versions they have all the providers inside that binary file. And for example, if there was a bug, they were not so fast to fix it. But in the latest versions, they have split all providers in this plugin system. So each provider has its own development pace. So for the main players, if it's in CloudFormation, it's going to be in Terraform quite fast.
If Terraform they didn't have don't have something that you need, you can also code up a provider of your own and simply call the AWS API and create your own resources or another API. So you are not bound to the Terraform team. So you can also create your own code. Yeah. I don't know if there exists some tool, but I don't know. Maybe I think
a lot of people that we know that they are using Terraform. His approach has been: we have a legacy infrastructure, and we are going to start using Terraform. The first step is we are going to import what we have into the state, and it's a manual process.
You have to define it first here,
and then import
in.
But I don't know if there is a tool for doing that.
The limit is defined by AWS. It's your account.
Yeah, it's by account.
If your account is limited to 200 instances, you can put there 200, but if you go more, it
will fail if you pass the limits.
As David told you, there is another file that when you run apply, Terraform creates, and it's called the Terraform TF state. This is a proof of that we have in this file is created in our provider. Here we have defined the load balancer with all the attributes that we have, the instance, security group, gateway. And this is a proof that we have here, it's created there. So unless if you make some manual change in the console directly, if you rerun Terraform, it will detect that there is different in AWS, and it will change it. Maybe we can show you there. So for example, we have the name that we added before, and sorry, and if we change it, for example, to this name, and we rerun Terraform plan to see what is going to happen.
It first checks the state of the resource, and compares it with what it had in the state file.
Yeah. So as you can see, Terraform has detected that the instance has a different name. So just is telling us, okay, I'm going to change this instance. If we run apply, it will change the name and nothing else.
So the source of truth for Terraform is the state file. Yeah. It doesn't matter what you have really in the infrastructure. That if you run the apply, it's going to try to move that infrastructure to what you have defined in the file. So the source of truth is the TF state.
As you can see here, the output that we defined before is located here. So project address and the load balancer URL. If we enter here is our web page. So it's a simple image. It's not recommended to edit this file manually because, as you can see, it has a complex composition. But if you want to edit manually because it's an emergency, or for example, if the Terraform apply has stopped because your computer went off or something, maybe your TF state is not reflejando,
reflecting.
reflecting the resources that you have in AWS. So in this case, as you have commands for Terraform import or Terraform export, you can remove resources with commands of Terraform. So it's easier for edit this file. We have edited in the past manually, and it's a nightmare. I almost leave my company. Okay, so what are we going to do now? We're going to edit this infrastructure. We are going to add another instance. So we can just copy this instance there, change the name, because we can have the same resource with the same name. And we want to have it inside the load balancer. So just we copy this. DevOpsSec is the name of the machine. Okay, so if we run another Terraform plan, it will tell you that sorry. Sec. That's it. Okay, it's checking again the TF states, and now it's going to tell us that it want to create a new instance.
And it's going to change the load balancer as well to
Exactly.
add the new.
It's going to create the instance and edit the load balancer. So we run Terraform apply. It's going to create it. Yes. Okay, and we can see that it's being created in here. If we refresh, okay, here is the machine. So once the instance is online, we will have two instances behind the load balancer. You can also configure the auto scaling, because it's a feature of AWS, so it's another resource of Terraform. But that's it. So okay, we have the instance running and behind the load balancer. This is initializing, so it's out of service. And okay, now we have two same instance, the same code. We have duplicated it. So Terraform provides you another parameter that is called count. So if you add this parameter, you can create as much instances as you want. For example, I can create 100. I'm not going to create it because it's it's going to a lot of money, but we can just add 2 and remove the another one. We can remove it because sorry.
When you use count, it's adding an index.
Yeah.
An index, okay.
Yeah.
Also, Terraform also have, you can use count dot index. So for example, the image is there. You can use this next. And for example, if you have an array and a variable with an array with different names, and you have 5 instances, you can run this array and get the names. So the count 2, we have to remove this because we don't have the instance, and that's it. If we run plan, it's going to tell us that one instance is going to be removed and another one is going to be created, because we have deleted the code of the another instance. So Terraform detects that there is no code for this, and is going to destroy it. The new instance, as you can see, there is an array, and that's it. Because we don't have this code we don't have the instance in our code. So Terraform detects, okay, in my TF state, I have one instance that is not code, so I'm going to destroy it. If we go to the documentation of Terraform, we can see there all the resources that we can create. Oh, a ver, sorry. Ya está, a ver si se ha pegado. API Gateway,
You have almost
auto-scaling,
everything.
Athena, almost every service that AWS has, is located here. So, for example, I don't know, the instance, that is the instance, oh, sorry. So, we have an example, the parameters that we can configure the instance with the ID, the availability zone, all of the parameters that we have. More things to configure, and in the end we have the values, that attributes that are exported that we can use in outputs. We can export the ID, the public IP. You have in the documentation, you have everything you need.
Finally, at the end of your resource, it tells you if it can be imported. So you use the ID that you have in the AWS, and it will check the API and import into your TF state.
Okay. So we can continue. Going to destroy the machine. Okay. Yes. And it's going to destroy the other and create a new one. We can see in AWS what's happening. Okay, shutting down this and creating another one. We didn't add the count index, so the name is the same. Exactly. And that's it. It's destroying it, and this is basically a basic approach of what you can do with Terraform. So we only have to destroy everything that we have here, and that's it.
Keep it working and go to the slides.
Okay, so we can run Terraform destroy, and it will ask us if this is correct. Okay, here it tells you what is going to be delayed. So the load balancer, the instance, everything you have in the code is going to be destroyed. Okay, bye. So it's now calling again the API and destroying all the resources.
How do we use Terraform when we are working as a team? But if you are alone, that is fine, because the TF state is in your local machine and everything. If we were working 2-3 people, every time that we wanted to make an apply, we had to share that TF state file. Okay, so Terraform provides resources to handle this situation, and one is the remote TF state. It's a way to store that TF state file in a remote location. It provides multiple possible backends. They call that backends. You can use Consul, etcd, S3, Google Cloud Storage, or there are Vault, I think, as well. And that is configured in the Terraform init command that Paco has shown you before. But this leads to another problem. What happens if 2 developers run the apply at the same time? So this leads to the locking. Okay, it has a locking mechanism. Not all the remote backends allows to use locking. Only a few. S3 use DynamoDB, and Google Cloud, I don't know. I cannot remember what it used. So it's checking if the state is being applied and is blocking any other apply. So that is not supported in all available backends.
For example, in AWS, if you set the locking, it creates a DynamoDB with a table and just with a flag. Okay, is locked or not? with a true or false. So every time you run a Terraform, it checks this table and told you if you can run the apply or not.
This is something that is in the Terraform, as all the HashiCorp world has its community version and the enterprise one. So the lock-in was available in the Terraform Enterprise before they made it available for the community. You should use a CI pipeline to do the automation.
See, locally we don't run any apply. It's in Jenkins or Buildkite. You have your code there, and every time you want to apply, so there is only one process by.
So as it's infrastructure as code as well, it should follow best practices or pull requests to be reviewed and everything. So that will be a problem,
Yeah,
for sure, if that happens. S3, and we are going. Why? Because we don't use any of the others.
Yeah.
No, I don't. I don't know. I don't think it's.
We are in AWS, so it provides H3. We didn't thought about that.
We are using etcd in our Kubernetes cluster, but we started using S3, and we hadn't the need to change. At Flywire, we have a playground account when we are developing new modules that we are going to show you later, and we use a separated environment to test everything before moving that to the staging production pipeline. We do use Jenkins for the deployment, the CI process, but in the new infrastructure that we are building, we're starting using Buildkite, and it's I don't know if it's like a scheduler that it's a software as a service. They provide you a web interface, and you install the workers in your machines, and through the interface you can build pipelines, and they have an API for automation and everything. We separate that by AWS account. We don't have two environments in the same AWS account. Okay, so we are going to see some examples in the build. So the first is with these examples we want to show the more advanced features like the modules. Okay, so this is a community Terraform code for bootstrapping in AWS WordPress in high availability using Ansible as a provisioner. We haven't told you about the provisioning capabilities. It's when you Terraform doesn't compete with Chef, Puppet, or they support all of them. So you have when you spin up an instance, you have a provisioner and you can run whatever code you want. So in this example, for example, they use Ansible for setting up the WordPress. Okay, what I want to show you here is the use of modules. Okay, modules is a way to split the functionality of Terraform and have reusable components. Okay, so we can split. Okay, this code is going to create all these things: an RDS, a load balancer, 2 instances in the VPC, all the networking, the DNS records. This module is going to create all these things. So all that can be put in a module. So what is a module in Terraform? Module is basically a bunch of files. Okay, we have inputs and outputs. You have it's like a black box. So, for example, this is the module for the load balancer. Each module has its own variables and main TF. It depends on the developer, but this is main variables and outputs TF is the agreed practice in the community. So you can reuse these modules in other projects. So the VPC is going to be the same for WordPress or PrestaShop or whatever you want to build. So this is, for example, the same for the DNS. So,
for example, if you want to, you have a module for creating an RDS, it's the database storage of AWS. You can have a module of RDS, and if you want to create 2 instances, and one of it is a read replica, in your code you have 2 modules, and this can be a module called MySQL read replica module, and you can use it in another.
You can reuse it.
Reuse it.
So here we have the modules, and for example, here in this is the main file. So you can see how it's using the modules. It's only, you have only to use the module resource, give it a name, and tell where the source of the module is. So this is pointing to the modules folder with the VPC subnet, and this is all the input variables. So you can create 2 VPCs simply by duplicating this code, changing the variables. And if this, instead of being a local file, this can be a Git with versioning, for example. That is what we are using at Flywire. The second example is about the multi-cloud functionality. So Tectonic is a brand of core OS that allows you to bootstrap a Kubernetes cluster very easily, and it's using Terraform and Ignition. Ignition is like the, I don't know, do you know Cloud Init? It's like when you bootstrap a machine, it's you can run some code for bootstrapping, installing packages, or everything. So Ignition is the Cloud Init version from Core OS. So if you, it's an open source project as well. And here you can see in the modules folder, they have the Terraform configuration file for all these providers. So when you run the installer, it's going to ask you, what provider are you using? And it's going to bootstrap a new Kubernetes cluster with, you can configure how many masters, how many workers, how many etcd servers do you want. And they divide only in 4 modules: the configuration for the etcd, the masters, the VPC, and the workers. You can check. For example, we're going to show you that Ignition thing. So it has templating. There are some advanced features inside Terraform that allows you to do the provisioning quite easily. You can do templating. It manages the idempotency of the files. If you change something in the file, it's going to detect it and bootstrap again and change the file and everything. Okay, and as I told you before, we are using Sumo for our log collection for all our infrastructure, our legacy and the new one. And this is not a provider that is supported in the core of Terraform. They don't support it. So the community is building all those modules that are not supported in the core of Terraform. So we arrived to a situation that we started using a feature of Sumo Logic that wasn't in this provider. So we created a pull request here, for example. So we added the functionality to a syslog shipper from our servers to this provider, and it took some time for the one who managed this to approve, but it was fine. So this is our files. We added the ability. We created a new resource for enabling Sumologic Cloud 6-log functionality, and we are using that in our infrastructure. There are quite a few Terraform providers. You can check the list in that it's quite big. This is the ones that are supported by them. There are quite a few. There are a lot of. It's also important to say that they support also bare metal, like for provisioning into bare metal machines, not only in the cloud. Anything that has an API, they are supporting it. So, okay, how are we using Terraform at Flywire? For giving you some context, we have been using it for 2 years. Our legacy infrastructure is using Chef and AWS with homebrew scripts. It was quite difficult to set up new environments. So we have 6 developer environments. This is a clone of our production functionality, but with smaller machines. And we have an staging environment and QA and a production environment. We started using Terraform, moving some things to Terraform. Okay. So we do heavy use of S3, for example. Like we have more than 100 buckets for the system. We use Dynamo, Elastic, Redis, Lambda, VPC, etc. For example, the developer environments we can spin up on demand, and we have only worked to fully automate the QA environment. We can bootstrap a new QA environment in less than 30 minutes right now, all with Terraform. I ask our older sysadmins or developers how much time was costing them to bootstrap a new environment from the ground up, and there were no answers. So because there are a lot of things that had to be done manually, there were a lot of scripts using the API, and it has been a big improvement for us. And we have stopped more or less to work in the legacy. We are moving more things to Terraform, but there are some things that we have been doing. We have been making modules of Terraform for some services like RDS and RDS backup. And with this, we are starting to experiment with testing and continuous integration for Terraform modules. What does this mean? That we are following the same development model than in the software. So we are testing we have a continuous integration process where we have the module, and we have testing that it's spinning up infrastructure, doing the testing, real infrastructure, doing the testing, and destroying it, and this and versioning, obviously. And it's working quite well, and it's we have only done with the RDS modules, and the RDS module, for example, it's not only spin up a new RDS cluster. We have lambdas to do the snapshots. We have an RTO and RPO limits, and we have the dumps. We have the move that dumps to the storage, and all that is tested. So we are confident that we can deploy that in production at any time. So, for example, in our main Terraform configuration, we only have to change the source that you have seen. If we are upgrading a version, a minor, for example, you only have to change that, and it's already tested, and it's working quite well. We are using Ruby and a gem called LW. We are using RSpec with a gem file called LWS spec. So once all is bootstrapped, we can check that the things that we want to bootstrap are in place, and then we have also integration test. Maybe we are bootstrapping a Bastion to check that the RDS and the networking is fine, and once all the tests passed, we destroy the infrastructure and mark that version as green, and to be able to integrate in the system. And finally, we have a new project. We are moving the new parts of the things that we are developing to a Kubernetes cluster, and we are using Tectonic. We have a basic setup of 3 masters, 4 workers, and 3 etcds. And not only the Kubernetes cluster, we are also bootstrapping all the Datadog checks. We are bootstrapping all the Bastion that is needed to connect to all the nodes for if you want to do some troubleshooting. And Sumo
Yeah, Sumo
PagerDuty as well. So we have all the infrastructure for this new project. It's in Terraform. So you can see here a screenshot of our CI for this cluster. You can see all the steps. For example, the set to prerequisites is where we set up all the Datadog and Sumologic resources. Then we install Tectonic, we have some test. Then we configure the Kubernetes cluster, and finally we do an integration test to check that it's all working as expected. So that is pretty much all. Thank you. I hope you have a ton of questions. And we are hiring.
Yeah.